Hi, everyone. As usual, we'll wait to around 11:10 to start. And as it was previously announced multiple times, today we'll first start with a quick quiz that will be open for you at 11:10. So please don't rush there. It won't be open until 11:10. So you should be able to start it there, and you will have 15 minutes to finish it. So it should be more than enough time. I think the quiz is only having 6 questions in it. If you have any questions before the quiz, please post it in the chat. The first question, is there multiple attempts? No, there's only one attempt here. Will it include this week's materials? Just a little bit. So it's not gonna have K-maps there, but it's gonna have some, some stuff covered from today's week. So that's what I said in the lecture, some of there. So it's mostly based on the last week, but there are a few questions from this week. So essentially the quiz starts at 11:10 and it has to be finished within 15 minutes. If you start a few minutes late, it will still give you 15 minutes, so it's fine. And after the quiz is done, then I'm going to talk about some, more complicated questions, and we'll go with you with several problems related to the materials covered this week. Any other questions, guys? So the answer is yes, some questions related to today's week's material will be there, but most questions are from last week. Other questions, why did we cover why buffers are useful? I didn't cover that in lecture, so it's not going to be covered. Like everything that was going to be asked in the test, it's something that so you won't going to be asked anything that was not covered in the lecture properly. So David is asking the question, if I start later, due date says 11:40. Yes, you can start a little later. You would have a due date 11:40. The only thing is that I'm not going to wait until then, so I'm going to start the tutorial before that. So you're going to miss some of the time on the tutorial. It will be recorded though, as usual, so you can read it, and watch it afterwards, but you won't be able to ask questions live if this happens. One thing I want to highlight about quiz, remember, this is not about to test your ability to Google quickly and things like that. Quiz doesn't really cost that much. So it's more like a lakmus paper to test on whether you're ready or not, right? So it is really like you want to understand how well you understand the material. It's more like testing yourself whether you're doing well or not. Like, do you understand in the material? If you can handle, after going to the lectures, reading through the materials, you can handle most of these questions, that it means you're doing well, you understand everything. Yeah, someone caught it. Yeah, sorry, yes. So it's 11:40 a.m., not p.m. So it's supposed to be finished. We just give you a little bit, like we didn't want to be precisely 11:25. So we give you some, if you're like a few minutes late to their class, you can still finish the test without any penalties. But it's not giving you time until midnight, no. So it's really this extra time is for people that are just slightly late. Maybe the team made the mistakes there, so it will give you more time. But I would highly encourage you to do it, you know, until 11:40 a.m. Let me change it. So I just updated the due date to 11:40 a.m. So thanks for a nice catch. So it's actually 11:40 a.m. So please refresh. You should see the changes now. Okay. Okay, any other questions? Yes, the quiz is only till 11:40, but it's really not that you had 30 minutes. So when you started, you would get a consecutive 15 minutes, right? So if you start a few minutes late, then you can finish it a few minutes late. That's what this buffer time is for. But I will assume the majority. Yeah, that was a mistake, and I just fixed it. So if you refresh, you should see it 11:40 a.m. Yeah, I checked everything for TAD, but I missed that thing. So someone caught it. Thanks a lot. And the correct answers will be released to you actually at 11:40 a.m. So you should be after the class. If you're curious, you can go and look, right? There are 6 questions. I tested on myself and on my TAs, so all of us can finish it in 5 to 7 minutes. So it should be okay with you. So I think 15 minutes is more than enough. And we're gonna have statistics after this class for quiz, so then we'll adjust accordingly later. Okay, I think it's 11:10, so you should be able to see the quiz now. So please go ahead and start, and good luck. And after you're done, please come back and we will do the tutorial. If someone can post here, say the tutorial started for you, please just say it started, so it's all fine. Now you have just one attempt. Okay, guys, we'll wait for a few more minutes. Most people are done, and then we will start the tutorial. And as usual, as we talked in the last lecture, if your environment allows you, please turn on your camera, at least for some time during the tutorial. Okay, I see that 85 people finished the test, so pretty much everyone who's on the call, more or less. So let's continue this. Okay, we will look at the statistics later. Yeah, I see that average is around 70%, and most people were able to handle most of the questions. We'll talk about the tricky questions later on. Okay, so the plan for today is twofold. So we had, the quiz, the first quiz. We will absorb the information. We'll see how well we did. I think if the average is indeed around 70%, I think that's what I was hoping for. So right now, we'll start with a very quick summary of what we covered so far in week 2. So you learn about using logic gates. You learn about combinatorial circuits, circuit reductions, K-maps. I guess to test your knowledge, a little bit of a tiny question here. So I'll ask you a question, try to post it in the chat. So we will test your knowledge of droids here. So the first one on the left, I assume you guys can see my mouse, that's Android, right? How would you call this guy here? So just post your, response in the chat. Oops. I don't see the chat somehow. What's going on? Yes, Nandroid. Great. So you got the idea. So this is Nandroid. How about this guy, the third one? So let's test your knowledge. Not showing. Okay, we'll keep it. Not droid, that's correct. And the last one is Ordroid. So I guess you now learn the symbols, so you should see them everywhere. Okay, let's go a little bit more serious. So what I'm going to do today, I'm going to show you a couple of typical questions you can be asked about the material, and something along these lines. First of all, it tested your knowledge. You should be able to understand how well you grasp the material from the Wednesday lecture. And essentially, then you can ask questions, and if you don't understand the answer, that's the whole purpose. So the question number 1 is how you can express a 2-input XOR gate as a combination of NAND gate and NOT gates, right? So try to do it yourself. Just practice on the paper, and then in a minute I'll show you the correct answers, and you can see whether you're right or not. Draw the circuit using only these 2 logic gates, NAND and NOT. So this is more like a practice for yourself, and then I show you the correct answer so you can compare. You cannot really, if you're really creative, you can try to post, a link to your image, but I think that's too much to ask. So just try yourself and then check later whether you did it right or not. Okay, let's look how it looks. So you obviously start with a truth table, right? So first of all, that's XOR, right? So you need to draw its truth table. So then the first thing to do is to draw XOR using existing circuits. So you would use AND, OR, and NOT. So essentially what's written here, it's not exactly what you want, but it's a first starting point. Essentially, you are having this guy, not A and B. That's the first part. And you had another one, A and not B. And they all feed it into OR. So if it's either this or this is two ones. This is going to build your circuit, right? And then we apply the De Morgan's law that we'll use all the time. And there we go. We're going to add nodes here, propagate them through the OR gate, and we're going to get NAND gate here, NAND gate here, NAND gate here, and two NOTs, right? Makes sense to everyone? So that's essentially how you convert XOR into simply using NAND and NOT. Okay, so that question number one, like a warm-up exercise. Then something relatively funny to do. It's quite easy, but you should try it out. Remember I mentioned that NAND gate is the only gate that can be used alone to implement everything else, right? So it's a really cool gate. So one thing to try out in this question is try to implement a NOT gate using a two-input NAND gate. And this is an easy exercise. You just need to tell me what should we put instead of this question mark here. Well, guys, if I'm going to put just an A here, what's the benefit of having two A's? Yes, that I was waiting for. It should be a constant one, right? If you're going to just do two A's, it's just a waste of input, right? So it's not going to change anything. But really what you need to put here, right, is one. But someone was correct, actually. Sorry, I'll take it back. If you actually use an A, that's another way to do it. Sorry. Yeah, there are two ways to implement it. I usually thought about constant. Yeah, so the people who said A is also correct answer. So both ways are legit. So this is the way to implement it. Usually just do it with a constant because in circuits, it's always cheaper to do it with a constant. Okay, so another question is about Minterms, right? So essentially what we want to ask in these questions, write why using some of Minterms that we learn in their lecture on Wednesday. So essentially what I'm expecting is to see the expression with Minterms, right? Yeah, so it's relatively straightforward, right? Everyone sees we're looking at these ones here. This is M0 position, this is M1, M2, this is M4, and this is M7. So if you do this, this is essentially two equivalent representations. This is using Minterms. This is if you take and expand each Minterm into its Boolean representation, right? That's exactly what this function y here represents. This is how we use Minterms. Okay. Any questions about that? Anyone puzzled about how to use Minterms so far? I think I spent a lot of time on Wednesday lecture, but who knows? Yeah. Okay. So the next slide is given the Minterms below, fill in the truth table on the right. So here again, I don't expect you to type. It's too much to type here, but this is more like I'm going to show you animated now, but it's more like to test yourself whether you understand how it works, right? So essentially, it's a very simple task. There's y, right? That's Minterms. So any term here corresponds to the 1, right, in here. So if you don't have M0, M1, what it means is it's zeros, right? So I hope everyone is clear about it. It's very easy to go from one into another. Really, Minterms is just a direct conversion from a truth table into the mathematical representation. And then the first one, we're going to get into M2 position. Then, because we had M3 term, the next one is going to be in this position. And then there are no M's until M7. So those are zeros up until this point. So M8 is 0, M9 is 1, and so on. So it's relatively straightforward. You should be very comfortable now going between different representations, right? Guys, any questions about that? Okay, that's good. So sorry for people that think that's easy, but I really need to make sure that everyone understands it, right? Because it will be more complicated material. It's also related to what you're doing in the labs. Okay, question number 5, that would be now actually more complicated, that would be dedicated to K-maps. So what is the most reduced form in sum of products of the function from the truth table on the right? So I'm going to give you 2-3 minutes to try to do it yourself. So essentially what you should do, as you know, our algorithms, you take the truth table, you write an expression out of it. So the first step would be to generate, sum of products. That is not the reduced form, right? So after that, you would need to use our favorite K-maps algorithm, generate a table for it. And with this table, you test your puzzle trick skills. You try to cover all the ones with the minimum number of boxes, right? I'm just reminding you. And then after and there can be overlaps, everything we practiced before. And after that's done, you should be able to generate the reduced equations. This problem is more complicated, so please try it on your own. And what I expect at the end is to see the reduced expression. So what was the most reduced expression you were able to get? It should take you at least 3-4 minutes, so I'm not going to bug you guys. I'll wait for a few minutes, and then for people that got lost, I'm going to show the non-reduced form first. It should be easy to get, and then I'll show you like gradually step by step what we're doing. But first, try it on your own. Oh, wow. So we got the answer, the first answer. And I don't remember the correct answer, but it looks like the correct answer. So let me start going over the solution. So that's the first step, right? I hope everyone got that. We just practice it. It looks like a huge expression right at the beginning. It feels like there's no way it's going to be any simple. Well, if you use K-maps, that it's possible. And I think without systematic approach, believe me, it would be very difficult for you to reduce it. So we write this table. I did it 2D by 2D, right? So I took 2 elements on the left, 2 elements, down, and AB down, and CD from left to right. And then essentially, if we use our representation, let's look at the animations. Those are 1s and 0s you get, right? That's the table I got, right? Then I did cover that. And what's really tricky there are multiple ways to cover this thing. And I'll show you a few cool stuff. So that's a straightforward way. There's this thing, right? With the full column of ones. There is this thing here in the middle, right? 2 by 2. And then there is this alone ones on the angles. But remember, those things can wrap up. So what I can do, you virtually can think about those things connected into 2 by 2 as well. They just happen to be at the ends. So really, there are just 3 elements of the equations here. So that's what we're going to get. We're going to get not C and D plus B multiplied by D plus not B multiplied by not D. This is one way of doing it, but you will see that's not the only possible way. So for people that might get a different answer, let's see how it can be done differently. That's another way of doing it. That's an alternative grouping. You start from the middle, you do this, and then you do this. And that's what you're gonna do. I'm gonna get this way. Okay. So this is the kind of a hint that leads to that. Anyway, this is, I show you more like the most complicated examples you might get with K-maps. Those are more complicated what you're gonna do manual. Right now, there are tools that help you to do that. But I hope that you get the insight on how to do it. Yeah. It's okay, it's just someone already had an answer, so I had to go a little bit faster. So it's like you're not going to be rushed usually too much. Yeah. Okay. So that was pretty much the main content I have for today. So this was all questions to refresh your knowledge based on Wednesday's meeting. And right now I'm happy to stay and to answer questions. Right. So one way to do it, if you guys are tired of typing, well, we got still a lot of students. So maybe you can just I think you can raise hands. And then we will test it. If it's gonna pop up people need that raise hand, or someone has a nice cat, that's cool. So cat is also attending the lectures. So raise your hand, right? The virtual hand. And then it should pop up you in the list because there is 80 something of you right now. So it's hard for me to move the list. And then if your microphone works, you can ask with the microphone your question. And otherwise you can just type it in. So I'm gonna monitor both things. So the rest is more like we're studying kind of unofficial office hours. If you don't really have any questions and it's all nice and easy and trivial for you, feel free to leave. Right now, I covered all the main content. We will announce the quiz statistics results soon. I think the correct answers should be out by now. So if you're curious where you messed up in one of the questions, then you can look it up. And if something is not clear, you can post questions on Piazza to get answers. But yeah, if you had anything specific you want to ask in front of the whole audience, please go ahead. Just raise your hand. Don't be shy. Okay, I don't see any raised hands. Yeah, so I got one request for the office hours. Essentially, I'll wait a few more minutes for any questions. I just show you those example problems. It's not exactly obviously the problems you're going to get on the quiz next week, but that should help. It should also help with your labs. Also, I ask my TAs to start recording some videos that would help you with pre-labs. So you're going to get soon see some videos posted. They're going to give you some helpful hints on the typical questions you face on the labs. So that would be supplemental material that you can watch. We try to keep them short, like 5, 6, 7 minutes. That would cover the labs, so it would be easier for you to handle it. I don't remember which question is what, but essentially there are some questions where you need to answer both things fully correctly to get a full mark, right? And in there was this one complicated questions with mean term, max term. They get like you know, a partial mark. Yeah, here for question 2, you need to select both correctly to get mark. Okay, guys, I don't want to go over each test of the quiz, so I will do it. So post your questions on Piazza so then everyone can see it and we will answer them there. Don't worry. Well, in question 5, why we put 2 x's? Well, that's to test your attention, right? There's nothing like really serious. Like we intentionally put x and not x, right? So to test your, your ability to be attentive, nothing else. And again, it's a small quiz. Got caught there. You make sure you don't caught on the big exam. So pay attention to little details. Okay. Any questions, guys? Okay. If there are no questions, then we're done for today's lecture. So people that want to have the office hours, please stay on the line. You can come with the questions and I will talk with you one-on-one. Okay, thanks everyone. Thank you for coming. And as usual, the videos will be posted up.